Hi, in this video, I'm going to talk about how do we test if an observed sample or a given sample is taken from a normally distributed population or not, right? You remember that when we were testing the hypothesis for a mean or variance in one sample or two sample test, the sample should be taken from a normally distributed population, right? Or the sample size must be greater than 30, or the sample size must be big enough. So now we want to test whether a given sample is taken from a normally distributed population or not. So all the methods we have learned so far to estimate and test population means and variances assume that the numerical value of the variable has an approximately normally distributed or has a normal distribution. None of the data are perfectly or 100% normal because the normal distribution extends to both directions with extreme small negative values and positive, very big positive value. Even some of the tests require other conditions such as the two sample t-test require the equality of the variances in the population, okay? Thus, if the population is approximately normal, all the statistical tests are still valid. So as just mentioned in the previous bullet point, what it says is none of the population is perfectly normally distributed. Okay, but if the population is reasonably normally distributed, all the tests we used so far still valid. Okay, especially if the sample size is large enough. So there are two different ways you can test the normality of the population from which a sample is taken. So one way is the graphical method, the other way is the statistical method, okay? In the graphical method, what you do is you draw a histogram or you draw a plot called qqplot or quantile plot, okay? So I'm going to show you how do we use the sample data to draw to test the normality of the population by plotting that sample data. Again, so this graphical technique is not very good way, especially if the sample size is too small. If the sample size is too small, then the graphical method does not show normality, okay, usually. But if the sample size is big enough, then the outcome you got from the graphical method and the outcome you got from the statistical method will be similar, okay? So let us talk about that, the graphical methods. The histogram, the first very easy method to test the normality, the histogram. We make the frequency distribution table for data and draw histogram if the histogram follows the normality. So what it means is, suppose you have a data like 2, 3, 5, 2, 7, 9, and so on, thousands of data there. Okay, suppose the maximum data is 50. So how do I draw the histogram of that? What you do is you make the class boundary or class limit, okay, and then you find out class boundary, and then you find out the frequency, right? And then you divide that into the group. For example, 0 to 9, and then 10 to let's say 19.5, and 10 to 19, okay, 10 to 19, and then 20 to 29, and so on. You make that, and then how do I make the class boundary? Is you do 0 0.5 to 9.5, right? Negative 0 0.5 to 9.5, and then so 9.5 to 19.5, you add 0.5 on the upper limit and you subtract 0.5 from the lower limit, and you continue that way. And there may be frequency like there are let's say 3 numbers between 0 and 9, 1, 2, 3, 4, 5, okay? So 6, right? So 6 number between 0 and 9, 10 and 20, let's say there are 26. Let's say 20 and 29, there are, let's say, 357, and so on, okay? Now what you do next is you just draw the class boundaries here, okay? Let's say this is -1, right? So from 0 0.5 to 9.5, right? This is 6. And from 9.5 to 19.5, that is 26. The another one may be 357, and then another one may be like this, and then like that. So you see that if it is a normally distributed, you will see a bell-shaped curve there, right? So that is one way. Okay, so we call that is the histogram. So we are using histogram. For the graphical method with the big samples, we can at least figure out whether the data is strongly skewed or bimodal, or if it has outliers. Okay, if it has a longer tail on the left or longer tail on the right, or if it has two peaks, you can find out if the sample size is big enough from the graph. Okay, beside the histogram, there is another other methods called like box plot or normal quantile plot, referred as a qqplot. This is more frequently used. Normal quantile plot, qqplot, are also used to detect the departure of the normality. So I showed you know how to draw a histogram, right? If in the histogram, if in the histogram you see that if the vertical line is in the middle and then the length on the left side and the right side are the equal length, then we can guess that the data may be normally distributed. So we saw that in your statistics class. Or if you make the histogram, if you see the bell shape there, it is also normally distributed, right? So there is another more frequently used graphical method to test the normality of the population of a sample. So that is called qqplot or normal quantile plot. Okay, some people call quantile plot as well. So this is what you will see. Okay, all right, let's talk about that. So qqplot is widely used to test the normality. This method is based on the fact that if the given n data are normally distributed, then you divide that you divide x-axis into n plus 1 sectors, and then find out the area under the normal curve, okay, between those sectors. And then and then assumption is those area must be equal if the data is normally distributed. So it compares each observation in the sample with corresponding quantile expected form from the standard normal distribution. Okay, we'll see the method. I will do manually and both by using R. The points in qqplot roughly follow, if the points in the qqplot roughly follow a straight line, that means the data are sampled from the normal distribution. The dots will, if the dot waggle around a straight line, then in that case it is not taken from the normal. If the dots are waggling around the straight line, not very far away, then you can say that the data is normally distributed. But if either on the left side or on the right side, if the dots are away from that line, okay, straight line, then we say that it may be losing normality there. Okay, if there is a strong departure from a straight line pattern, it indicates that the frequency of the population likely deviates from the normal distribution. Okay, all statistical software give you normal qqplot. In the following slide, I'm going to show you how to do that manually. Okay, so these are the steps to find out or to plot the qqplot. Okay, number one is, first of all, you should arrange the data in the ascending order. For example, look at this example. So here, what I have done is I'm asking you to test the normality of the population where this data is taken from. Okay. So first thing you do is you write the data in the ascending order. That is the ascending order of the data. Starting from the smallest data, go up to the biggest data. Okay. And then you find out the x bar, meaning the sample mean of that data, and then standard deviation of that data. So I found the x bar and the standard deviation of the data. So the next thing you should do is using the rank of each data. Now we need to rank. So first, the smallest one is 1, and then second smallest is 2, and then third is like that. You rank the data. Okay. After you rank the data, so using the rank of each data, evaluate the left area. How do I find out the left area? Using left area L equals to I is the rank minus 0.5 over n. Okay, so L equals to I minus 0.5 over n. That's the formula you use to find out the area left of a given particular area left of a of the rank of the particular data point, okay, where I is the rank of the data and n is the total sample size. Now after you find out the left area, you find out the g value by using the q norm and then that L, okay. So after you do that, find the expected value by using y equals to x bar plus s times g for each data point x, okay, because you will have different g for each data point, and then you use this formula to find out the expected value of each data point. Now you plot x versus y, or you plot x versus g value, okay. If the plot is close to a straight line, the data is taken from a normal distribution, otherwise it is not, okay. So I am following that step here to check the normality of the population of this sample. First I arrange that into the increasing order. I found the sample mean of that, and the standard deviation that. So it is easy to find out the mean and standard deviation using R, right? What do? You do mean of, you just copy this data, and then do in the R, you can do let A equals to C, and then paste that and close the parenthesis, right? And you can find out mean of A, SD, and then inside the parenthesis A, you can find out that way. So you find out the mean and standard deviation. After you do that, you find out the area L by how? What you do is you find out the rank of each of the data, okay? After you find out the rank, you do rank minus 0.5 over the total number of data points. There are 9 data points here, 1, 2, 3, 4, like that. So there are 9 data points. What you do is you do I minus C, 5 minus, so this 5.79 is the rank of that. Is rank means from smallest to highest, assign a number starting from 1. 1, 2, 3, 4, 5. See, for 5.79, what is the rank? It is the 5th lowest, right? So you can do, this is 5 minus 0.5 is 4.5 divided by 9. So 5 minus 0.5 over 9 is 4.5 over 9, okay? That is 0.5, so 50%. So in that way, you find out the area left of each of these, rank of each of these data points, okay? Similar, how about 5.89? What will be the left area? It will be 1, 2, 3, 4, 5, 6. So 6 minus 0.5 is 5.5 over 9. That will be the area, and so on. Okay. So you find out that for all of those, and after you find out these left area, you find out the, so this should be Q norm, okay. So this is the calculator syntax, is inverse norm, but in the R you can use Q norm of each of those these values, these areas, okay. So that will be, you will get 0.5 here, you will get 0.3889 for this one, okay. For that one, so don't worry about this method, because I went a little bit conceptual here. What I was trying to do is, you see that if you want to find out the area left of 5.79, then how do you find out that? How many data are there? 1, 2, 3, 4 data, divide by 9, that's what you get. But if you want to find the area left of or equals to 5.79, you go up to here, 1, 2, 3, 4, 5 over 5 over 9, right? That's what you'll do, 5 over 9. But so if you want to, so see, that is the difference here, right? For 5.19 it is, for less than that it is 4 over 9. For less or equal to that it is 5 over 9, right? So just go towards the middle of those. That will be 4.5 is the fourth, 5.19 is the fourth data, and 5.79 is the fifth data. So middle of that is 4.5. You can do 4.5 over 9. That's what I was doing, all these two first and second lines here. Okay. Now after you find out the find out the area. These are the area values. This one and this one will be 0.5 will be the area values there, right? After you find out the area, you need to find out the G value by using the inverse norm or the Q norm. So it should be Q norm of that area. It will give you the G value. After you find out the G, you already have X bar and S. You use that the expected value as X bar plus S times G, which is if you apply that for this value, you will get 4.86 and so on. This is what I'm showing here. Okay, I'll show you how to do by hand in R as well. Okay, but for now I'm showing all this work in Excel. So what did I do? I wrote the ascending order data in the first column. Data is 3.77, 4.25, and so on. I copied that. Okay, next I assign the rank. This is the first lowest, second lowest, third lowest, 4, 5, 6 up to 9. Now how do I find out the left area? To find out the area left of 1, you do 1 minus 0.5 divided by 9. That's what you get. 2 minus 0.5 divided by 9 will be this. 3 minus 0.5 divided by 9. 4 minus 0.5 divided by 9. 5 minus 0.5 divided by 9, and so on. You do that way. Now to find out the G value, what do? You do Q norm and that number. Q norm, that number. Q norm, that number. Q norm, that number. Q norm, that number, and so on. This is how you find out the Q norm. Okay. Now how do I find out the expected data? So to find out the expected data, what do? You do X bar plus S times G. So X bar plus S times G. What is our X bar? 5.52 plus X is, S is, what was S? S was 1.18 times. This number will be that. So 5.52 plus S is 1.18 times, that will give you 4.38, and so on. This is what you get. So I just copied this data again here, observed data, just to put them together. Now what you do next is you plot this versus that. Or sometimes people plot G value versus the observed data. So G value versus the observed data, or you can do expected data versus the observed data. Okay, so this is what you get. Okay, you see that this is almost near a straight line. And again, when the sample size is small, it is hard to say for certainty that if the sample is taken from a normally distributed population. But if the sample size is big enough, you will get the same result from the graph or qqplot or from the actual statistical test. Okay. So finally, we plot the expected x-axis and the observed in y-axis. You can plot G value versus observed data too. The almost straight line in the qqplot indicates the data is approximately normally distributed. Okay. So if you can do all these things directly from R, just one line code. So what did I do here? Y equals to C, and then parenthesis, I copied the data, get the given data. Did I copy the same given data or no? Oh, it sounds like I'm skipping some of the data here. So what I can do here is, so maybe I was taking different, I don't know. I was taking, so how many data points are here? 1, 2, 3, 4, 5, 6, 7, 8. Oh, that's the same data point. But I did not, you see that I copied from the non-sorted data. Still fine. Whenever you're using R, you don't have to sort the data. So you copy just Y equals to C and then that data point, and then you do qqplot Y, because that is the Y is the data point. Or you can do QQ norm Y. If you do that, then you will get the qqplot. Okay, let me show you how to do R on that. So this is the data point. I am doing by manually first. Okay, so Y equals to C, that, right? And then I am sorting that first. Sort Y will give you the value in the ascending order. Now I am giving the rank of that. Rank is 1, 2, 3, 4. So R equals to rank of S. That's what I am doing. Okay. Now after we find out the rank, how do I find out the area left of each of the rank? Is that rank minus 0.5. Rank minus 0.5 divided by the total, how many data points are there. That will be given by length of Y. So the rank minus 0.5 divided by length of Y. We'll find out left area for each of those. We did that. Now we need to find out the G value. How do I find out the G value? Q norm and then left area. So Q norm and LA is the left area. So I did that. So if I plot that G, I got these values there. Okay, so that is the G values. Now to find out the expected values or expected data, what you do is you find out X bar. You see that? X bar plus S times G. So it is mean of Y is the X bar plus SD of Y is the S standard deviation times the G. That's what I am doing. And if I run, this is the expected data. Now you can plot either the expected value and then the S is the sorted value of that. Okay, expected value or the sorted value, like this. Plot like that. You see that these are along with the straight line. Or you can plot G versus S. So G is that G versus S is the sorted one. So you get the same plot, only the difference is you will get, when you do G versus S, you will get G values this around 0. But if you do YE versus S, you will get Y is the expected value versus the observed value in the ascending order. That's what you will get. Okay, but what is the direct code? Direct, just one line code there is, what you do is you do QQ norm Y. What is Y? Y is that data. First of all, you enter the data and then do QQ norm Y. Let us see that. QQ norm, you exactly got the same thing there. Okay, so same plot there. All right, now, so if you want to know whether these data are close, you can see that the data are close, right? Close to a straight line. But if you want to draw the straight line and then say, what you do is you do QQ line Y comma color equals to 2. Okay, so adds a line that pass through Q1 and Q3. That is the QQ line is the, it will draw a line that pass through Q1 and Q3. That is the first quartile and the third quartile. If you do that, see, all these data are close to this straight line. So you can say that maybe the data are taken from a normally distributed population. So if you want to so the next thing we will learn is we will try to do the statistical method to test the normality. Okay, now let me give you one more example on the qqplot method. So let us see what, so do you remember the tooth growth data? They provided the so tooth growth data is they did an experiment providing a different vitamin C supplement with different doses, right? And then they wanted to see how the tooth, what is the length of the teeth. That's what they studied on this experiment, right? So what I'm going to do here is the length column is taken from, is the population of the column of length is normally distributed or not. So what I'm doing here is I am writing x equals to tooth growth, the first column of the tooth growth. That is the x, and then when I printed that x, these are the values. Okay, so this is the total data points on the first column. Now I want to know whether from drawing the QQ plot, whether these data points are taken from a normally distributed population, right? Let us do that. So this is the data. It sounds like it is normal because all these data points or all these values are close to a line, but you can draw a line from Q1 and Q3 and then see that. Okay, although on the very left end and the right end, it is a little bit deviated kind of from this line, from the normality. So but still it is not much like worse deviation, but you can just guess from the plot, right? But you cannot say for sure whether the data point is randomly picked from a normally distributed population or not. Okay, so the next thing I want to do in the next video is how do I use statistical method, like find the p-value and reject and don't reject the null hypothesis. How do I do that? The statistical method to test the normality of the population of a given sample.